Amyloids are a class of protein that have the propensity to form plaques in between the spaces of cells. This is pretty easy to understand by having a look at a picture. Here's an area that is normal. Here's an area that's affected by amyloid plaques. The most famous of these amyloid plaques is the amyloid that causes Alzheimer's disease, beta amyloid. And in order to get an understanding of how these plaques are formed and the damage that they cause, what I'm going to do is put a link to a PBS video. It's about 4 minutes long, and it does a very good job of explaining how these plaques come to be, the protein responsible, and the ultimate effect on the tissue and the organ as a whole. If you can understand one of these amyloid diseases, then it's easy to understand the other ones, because the other ones are only going to differ by the protein that begins clumping together and the effect of what that does, depending on what tissue it is. If something accumulates in the brain, that has a certain effect. If something accumulates in the heart, that has a certain effect. Something accumulates in the kidney, that has a certain effect. So I'll put a link to that video. Go ahead and watch it and then come back. Alright, so now that you see how the miscutting of certain protein causes it to be more likely to stick together, and then over time these things develop into something that is pathological. Same thing can happen in different tissues. We don't really know so much about many of these because for the longest time, well, I'll go back up here, for the longest time people did not really pay much attention to them, with the exception of beta amyloid because of Alzheimer's. But what was found over time, when they started dissecting or performing autopsies on people who lived to be very, very old, super centurions, they discovered that most of these, here it says 70% of super centurions, were felled by some form of amyloid. So people started looking more closely at these. People had known about them for a while and knew obviously that they were bad, but since they could not be tied to some kind of pathological disease, with the exception of Alzheimer's, not really much was done about it. Here's a list of different amyloids that cause different pathologies. Some of these amyloids are a problem of a miscut protein, like in beta amyloid. Some of these just occur naturally, like this one right here. This is a protein that transports thyroid hormone, and just over time, through a lot of use, it can be bent out of shape, and then eventually it can cause one of those events where it conglomerates. Some of these are genetic. They have different causes, but the end result is the same: a buildup of a plaque in the tissue of some organ. It can be any organ, or it could be the skin, it could be the eye, it could be the brain, it could be the kidney. Actually, one that they've been looking into recently as a potential cause of diabetes is this amylin. And what they're finding is that this is forming a plaque that is killing off cells that produce insulin in the pancreas. And, oh yes, I forgot to mention, the body does in fact respond to these plaques, to some of them. Some of them it doesn't seem to recognize, but most of these plaques, to some extent, the body's immune system, I don't think was mentioned in the PBS video, but the macrophages of the brain actually eat the plaque, but they just don't get rid of it quickly enough, and that's the problem with a lot of these plaques. Macrophages, or different mechanisms used to get rid of generally macrophages. They eat this plaque, but in some cases, this is what I want to do. I want to tie it back to the lysosome dysfunction. Some of these cases will be able to be solved by giving the right enzymes to macrophages or whatever cell is responsible for getting rid of that plaque. Because in some of these tissue samples of, say, people that they autopsy, they'll notice that macrophages are in the vicinity of all of these plaques and they're digesting it, and two things are happening. Either one, they're just simply not able to keep up with the load, it's too much, or two, they're finding that the macrophages are becoming swollen because of that problem we discussed last time. They're just not able to digest it. So I wanted to mention that before I forget about it. But let's continue. So these are just different kinds of amyloids. There are probably more. I think there's one on here that I remembered that I didn't see, but it's a pretty comprehensive list. So we'll just look quickly at, because it's very easy to understand. You have stuff building up in between cells. Obviously it's not good, and it causes tissue, organ dysfunction, all kinds of problems. Here we can see a cardiac amyloid, and this is responsible for a lot of people's deaths in older age, particularly in supercenurions, people who are 90 and older. But just because it causes their death, this is what generally they mean by death by natural causes. One of these amyloids, generally a cardiac amyloid, builds up, and that's just the way it goes. But you can see here this really nasty looking gross goop stuff. That's an amyloid deposit. And besides from it possibly killing someone, it's a big cause of exactly what we're concerned about. We're not necessarily concerned about a length of life. We are, but people are more concerned about the quality of life. And this stuff building up in between the cells of different organs and just causing it just to get worse and worse and worse. This is a big driver in aging. It's just causing a system-wide dysfunction wherever it builds up. So you can quite clearly see that. We'll just look at a couple more examples. Here is a kidney sample. You can kind of see this whitish off-color stuff. That is an amyloid plaque. It can also build up in the skin. This is what causes a lot of skin stiffening in age. It also causes the stiffening of the heart as well with age. But this, I know it looks like melanoma, but it's not melanoma. It's an amyloid deposit. And this is just a very extreme example of an amyloid deposit, but it's building up in small quantities in the skin and other organs. It doesn't necessarily build up evenly throughout an organ or throughout the skin or throughout any other place, because again, in order for this to happen, you have to get like a traffic jam, and then it just builds on itself. It's like a snowball effect. It doesn't evenly distribute. And one more here is an example of a liver. So here you can see the off-color bits. That's amyloid plaque. Let's see if there's anything else I had on here. Oh yeah, they've got I guess I'll talk about this next time, but now they've got better ways of diagnosing these kind of things. As I said, for the longest time, people just ignored it. The only way they could tell if someone had it for the longest time is if they just took a tissue sample, and normally they're not going to get like for the heart, that's very difficult, but other ones not so difficult. But hopefully this gives you a pretty basic idea of what amyloids are all about. That video, if you didn't watch it, go back to that video. That video does a really good job of explaining exactly how it starts and what the end result is. And you just basically apply the same reasoning to all of these other amyloids. They're caused by different proteins, but the end result is the same, a plaque building up in between the space of the cells.